Okay, let me introduce the paper. The title is a dynamic QoS routing mechanism for deep space network based on SDN architecture. The introduction includes 4 parts. The first one, introduction. Deep space exploration is an important way for human beings to explore the unknown world. It is an important trend of development for the integration of deep space communication network with near-Earth satellite network and terrestrial internet, which is considered by many researchers as an important part of the next generation internet. The deep space network is well known for its long delay, asymmetry in uplink and downlink, and so on. The network is also limited by the computing and storage capability of the network nodes. Deep space networks routing often uses static methods or a combination of dynamic and static methods. With the expansion of the deep space network, the number of nodes continues to increase. The type of data transmitted in the network are becoming more abundant, and the amount of data is also increased sharply. Continued use of this method will make the network routing configuration and switching more complicated. They are not considering the load status of the node, so they may also cause the node to be overloaded, cause serious packet loss rate and time delay, and even a sharp drop in the performance of the entire network. In order to alleviate this situation, researchers have tried a variety of solutions. This paper proposes a dynamic routing mechanism based on SDN architecture for deep space network. According to the status of the deep space network QoS guarantee capability, the target node can be found, while avoiding extensive loads on nodes and affecting network performance. The second one, starter. SDN technology is a new technology in the research of network architecture in recent years. It realizes flexible control and centralized management of the network by separating control from data and combining programmable control. For the actual deep space network, the control plane is responsible for collecting network-wide information and performing complex routing calculations, and then sending the routing rules to the data plane node. The nodes of the data plane no longer need to perform tasks such as complex calculation, state acquisition, and heavy storage. They can focus on data forwarding. This feature of SDN technology is very suitable for satellite nodes with severely limited resource. It can effectively reduce node of overhead and ensure more stable and efficient operation of satellite network. The control plane needs to complete functions such as node search, state collection, routing calculation, role distribution, and so on. It requires higher basic performance such as higher processing power and storage capacity. Therefore, the control plane nodes are always placed on the ground. Also, this method can solve the problem of basic capabilities of the control plane. It is not suitable for the condition of relatively limited distribution of ground station. When the satellite nodes are not in the coverage of the ground station or belongs to a long distance deep space communication scenario, it is impossible to deliver the uh, control information to the nodes in time. The transmission time may be several hours to more than 10 hours, which will be difficult to adapt to the higher real-time and dynamic requirement of future satellite network. This paper proposed a satellite network model with a master-slave controller structure called SADR model, taking the Earth Moon communication scenario as an example. The control plane is a two-stage structure. The master controller are placed on the ground to undertake heavy storage, analysis of the node status of the entire network, complex routing calculations, and node switching control functions. In addition, this type of node usually has a higher basic performance than the normal satellite node, so it can also ensure a higher work efficiency when implementing the controller functions. The slave controller nodes mainly undertake the new node discovery, node status collection, and send to the master controller. When the node in the deep space network move in the space, the type of user traffic and the size of application data they serve will change. If these nodes are in one or several important transmission links in the hotspot area, it may cause communication data blocking on this node. Given a graph and the connection request from the source node to the destination node, the purpose of routing is to find an optimal path with minimum cost from the source node to the destination node, which meets the QoS requirements of users. The goal of SADR routing algorithm is to find a better path P from the source node and the destination node by combining the short delay path and the basic performance of the node. SADR will choose the nodes with shorter delay, large available bandwidth, smaller number of link interruptions, and higher pheromone strength as the basic of the next hop routing algorithm. Pheromone plays Pheromone plays a very important role in path selection. It changes with the process of searching and destination node. The higher the pheromone strength is, the more ants will be attract to pass through the node. After the ant completes a node selection, the node is placed in the visited node set. and then the pheromone is updated locally. When the complete path from the source node to the destination node is completed, the pheromone of all nodes on the path is updated globally. Starter will give extra bonus to the path that has completed end-to-end communication and the area QoS value of the path is the best. For deep space network, due to the characteristics of long delay, high dynamic, and high packet loss rate, in addition to the nodes and link that meets the delay requirement and have good QoS, the path will with less link hops should be selected as far as possible to further ensure the reliability of data transmission on the path, reduce the cost of the whole network system. The basic idea of SADA is to learn from the algorithm and periodically find the optimal path from the source node to the destination node to meet the user's QoS requirement. SADA is mainly divided into three phases. Firstly, in the initialization stage, there is a set of default topological connection relationship, which can ensure that the entire satellite network can maintain data communication in the initial state and or emergency state, even if it is not a perfect routing mode. And then it acquire a state information of the deep space network node by the slave controller and summarize the state information to the master controller. The master controller performs dynamic QoS route calculation according to the SADA algorithm. Because of the constantly moving of the satellite nodes and the changing of space environment, the path found in the previous stage may not be a high quality path or even a usable path after a certain time interval. Therefore, it is necessary to send an update cycle. Finally, in the routing table distribution stage, the master controller distributed and calculates routing tables to the slave controller, and then the slave controller forwards the received routing table to nodes covered. The third one, performance evaluation. For different satellite network routing algorithms, the end-to-end delay of the network node is a basic network performance indicator, which can explain the rationality of the network architecture, and the end-to-end QoS status value can reflect the current QoS status of the node and link on the selected path. The finger shows the end-to-end QoS status value and delay returned by SADA and QDA respectively. SADA plays better than QDA. The fourth, Conclusion. SADR is a dynamic routing algorithm for deep space network based on SDN architecture. The algorithm is mainly composed of the following parts. SADR dynamic routing lookup process. It acquires state information of the deep space network node by the slave controller and summarizes the information to the master controller. The master controller performs a dynamic QoS route calculation according to the SADR algorithm. SADR routing table distribution stage, the master controller distributed and the calculated routing table to the slave controller, and then the slave controller forwards the received routing table to node cover. Finally, the simulation result shows that the SADR has better performance in end-to-end path QoS state value and end-to-end average delay. That's all. Thank you.